Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Comets, Planets, and Crustal Displacements. Now, as detailed in Article 168, Electrical Sun and Toroidal Envelopes, and Article 169, Planetary Formation, Comets to Planets, comets develop tails and comas due to the fact that they are moving through the Sun's area of influence, which is actually in the form of an electrical capacitor dominated by a non-constant electric field. When in this field the comet nucleus emits light, the light is caused by the electron current coming from the Sun, reaching the comet and interacting with the positive ions that are being drawn from the nearest nebula ion cloud to the comet, but on the opposite side of its orbit to the Sun, as illustrated below. So here we see a comet entering the solar capacitor, or the solar system, and it will cross equipotential surfaces, or surfaces that have the same potential all along them. And as they cross the different surfaces, the capacitor discharges. That is, it charges the comet, discharges the capacitor itself. So charge is transferred from the capacitor to the comet in order to try and equalize its potential to its environment. So the result is a current of electrons coming from the Sun towards the comet, and the current of ions coming from the nearest nebula cloud, and these meet at the comet. Now, the brightness of this light emanating from the nucleus is determined by how large the electron current is, and this in turn is determined by the comet's orbit and by its size. So the more elliptical the orbit, the faster the comet will be moving through equipotential surfaces, and the more current it will therefore draw from the capacitor plates. So there will be more electrons coming in and more ions coming in, and therefore there will be more interactions, and therefore more interactions at the comet, and therefore it will be brighter. Now, if it's also a very large comet, then the larger surface area will attract the current. So larger comets will attract more current and glow more brightly. And here we see a green comet. It's emitting mainly green light. The tail seems to be more blue. The brightest portion on a comet is usually the sunward side, close to the nucleus. So this region over here opposite to the tail. Thus, the most energetic comets will emit the most energetic light, including X-rays, but the human eye will not see the X-rays because the human eye only detects visible light. So the human eye will only see the visible light that comets emit. And the most energetic visible light is blue light. So the more energetic comets will be more likely to emit blue light and will look blue to humans. Now, the tail will also emit light due to ions in the tail also capturing electrons. And this is because some of the electrons getting to the nucleus will continue moving on into the tail and interact with the ions in the tail, and the electrons become captured, and when that happens, photons are emitted, so light is emitted. Now, the electron current is usually invisible unless the comet is very large, and even then it is only visible close to the nucleus. When it is visible, it looks like a sunward spike on the side of the comet opposite to the tail, and this can be seen here below for comet Urbain LeVerrier, which made its passage through the inner solar system in 1957. And this comet had a sunward spike, so a strong electric current arriving at the nucleus and emitting so much light as it interacted with the ions here that it became visible. Now, when a planet passes through the tail of a comet, the material in that tail may end up entering the atmosphere of that planet. And there can be a lot of water in the comet tail, in which case a lot of water will enter the atmosphere and possibly fall as intense rain on the planet. And the water, which is 2 hydrogen atoms and 1 oxygen atom, is formed from hydrogen nuclei. Hydrogen nuclei are actually hydrogen ions, and an ion is an atom that has lost some of its electrons, so it's become positive because the protons in the nucleus are positive and there are extra protons in comparison to the number of electrons. Hydrogen is the simplest atom. It has only 1 proton in the nucleus and 1 electron outside the nucleus, orbiting the nucleus. And when an hydrogen atom loses its electron, then what is left in the nucleus is just a proton, which is positively charged. So it becomes hydrogen nuclei, which are hydrogen ions. Oxygen, when it loses 1 electron, becomes an oxygen ion. So we can write it as O with a plus, meaning 1 plus electric charge. And if these come from the nebula clouds, then when these ions interact in the presence of electrons, we end up with water. And this is illustrated here below. So we have an oxygen ion and 2 hydrogen nuclei or protons, and all of these will capture an electron, so they'll become neutral. And once they become neutral, they can react and form water. This chemical reaction releases a lot of energy in the form of heat, and that goes into heating up the comet. But the reason why they don't interact, or these ions do not interact unless they have captured an electron, is that they are positive, and positive particles repel each other, so it's difficult for them to react. So they have to become neutral before this reaction can occur. Now, if the tail contains large amounts of sulfur dioxide, then the sulfur dioxide may end up entering that planet's atmosphere if it goes through the tail. So if the Earth were to pass through the tail of a comet with a lot of sulfur dioxide, then in the tail, then the sulfur dioxide would enter the atmosphere. But sulfur dioxide combines with water in the atmosphere to form sulfuric acid or acid rain. And this can be detrimental for plants because it dissolves minerals in the soil which plants need. And this would eventually cause plants to become diseased and eventually die. So this could be a big problem for our planet, and could, if a large amount of sulfur dioxide enters, could be catastrophic. Then if carbon and hydrogen is pulled in from the nebula ion cloud, these would react to form hydrocarbons, or in other words, oil, because that's what they're made out of, carbon and hydrogen. And they would form in a similar way, or form these compounds. And these can occur in the coma or the tail. All of these can occur in the coma or the tail. And but it's much easier for a planet to go through the tail than to pass close enough to the coma of a comet in order to interact with it that way. But if a planet passes through a tail which has hydrocarbons in it, then these may enter the atmosphere and fall as liquid, because some are liquid at room temperature. So as they enter the atmosphere, they'll cool down, become liquid, and form huge pools and lakes on the surface of the Earth of this oil. Some of it would, of course, drain into the ground and may be what causes the Earth to have these extensive reserves of oil. And if they were to fall on animals, they would most likely drown the animals. Now, the worst effect is actually when a large comet nucleus passes very close to a planet. As the comet approaches, there may be huge lightning-like discharges between the two objects. Then, once an electric connection is established, gravitational attraction takes over, and the object with the largest mass will pull all liquid and gases from the other object. So a planet having an encounter with a comet that is larger than that planet will lose its oceans and atmosphere, whilst the comet will gain a lot of gases and liquids. Since the comet will be very hot as a result of this discharging process, any liquids will most likely turn into gases in the comet's coma. And this may be what happened to Mars. Mars has a very thin atmosphere. It's basically a dead planet now. But there are signs that Mars used to have oceans and rivers, because it still has intact ocean ridges and meandering riverbeds, of course empty of water. So it seems that Mars may have had one of these encounters with a comet, perhaps only a few thousand of years ago. And what would happen then is the comet was larger than Mars. Then once the electrical connection is established, it would start pulling these gases and liquids from Mars' atmosphere. So it would take all of the oceans and most likely most of the atmosphere. Now, the reason why this possibly only happened a few thousand years ago is, well, we can see it because these features, the ocean ridges and the riverbeds, haven't eroded away. So this couldn't have happened such a long time ago, because if it had happened millions of years ago, then because Mars has these huge windstorms, they would have eroded away a long time ago. So these were still there not so long ago, for them to still be so clearly discernible on a Mars surface. Now, in addition, impact craters on Mars can be found on the continental masses, but not where there used to be oceans. And this shows that when the impact occurred, then the craters that formed on the ocean were quickly eroded away by the water in the ocean, but the ones on land would have eroded away much slower. And this would be the reason why you find them on land and not where the oceans used to be. But if Mars had lost its oceans millions of years ago, both the craters on land and in ocean basins would have had the same degree of erosion. So they would either be all gone or still all be there, both in the ocean part of the surface and the land part of the surface. So it seems that Mars has had this encounter with a comet that was larger than it is only a few thousand years ago. Now, according to the Bible, the Earth also experienced a water deluge a few thousand years ago, and it's likely that therefore the same comet that lifted Mars' oceans and most of its atmosphere from its surface may have had an encounter with Earth as well. But Earth is larger than Mars and must have been the winner this time, so that water in the comet's acquired atmosphere got transferred to Earth, falling through the atmosphere as torrential rain and causing a worldwide flood. This would then indicate that the comet was more massive than Mars, but less massive than Earth. And the comet must have, however, have been planetary sized and therefore very likely to be close to ending its development, which would end with the comet as a captured planet. Now, of all the planets in the solar system, Venus is the best candidate as such a comet. Venus is hot and very volcanically active, and therefore the most likely newest planetary addition to the solar system. Now, this is what may have occurred with Earth. This huge comet, possibly Venus, came by, established an electrical interaction. There may have been a lot of discharges which would have ionized the atmosphere, would have caused earthquakes, volcanic activity inside the Earth, and then we would have got the connection. After that connection is made, we would have a transfer from the lightest of these objects to the heaviest, and the Earth was obviously the more massive during that exchange. So a lot of the ocean that possibly the Venus had acquired from Mars ended up going into Earth's atmosphere and then falling down as rain. The gravitational interaction would also have caused a tidal wave, and as this tidal wave moves, it actually causes the outer crust and upper mantle to detach from the inner core. So you would rotate freely in whatever direction it would tend to rotate, and thus causing the magnetic poles to, once this it stopped its rotation and connected again to the core, to be in a different place completely. So the magnetic field is made up of two parts of the inner core. Both must be permanent, as I've explained in a previous article titled Article 167, entitled Magnetic Pole Shift and Crustal Displacement, where I explained that. But the magnetic pole would have changed, say, from one position there to there, the North Pole. And we can see here then this line of magma flowing to the surface due to the seismic activity induced on the planet would, as I have shown here, would be in a different position. Here it's over there. And the cracks formed by the seismic activity or earthquake activity over here would have moved to there. And as the comet moves off, then this water that came in would fall down and form much deeper oceans on the surface of the Earth. And all of this would cause many more cracks in the crust and the upper mantle to form more volcanic activity as the planet reacts to these great changes that have just occurred. Now, the close approach of a planetary-sized comet to Earth would have also caused extreme earthquake activity, as I have shown, and create this tidal event that would shift the poles. And then as the comet moves off, it would regain contact, and we would see the magnetic poles in totally different positions. Now, comets also seem to have an effect on the sun. When comet Hale-Bopp, which was discovered in July of 1995, came through the inner solar system, the sun was observed to have huge CMEs in its direction, and thus in response to the comet discharging the solar capacitor. Comet Hale-Bopp was extremely bright and large. The nucleus was most likely the size of the moon. At the same time that the sun responded to the comet's presence in its area of influence with huge CMEs, the Earth was also impacted by stronger storm systems than usual, showing that weather systems on Earth are driven by solar activity. This occurs as the sun, through the solar wind, ionizes the Earth's atmosphere, which in turn electrically drives low and high pressure systems in the Earth's atmosphere, as I detailed in Article 122, Electric Weather, Why is it Getting More Severe? Now, the fact that the Earth is experiencing severe weather phenomena may be an indication that it is being affected by an object in outer space not far from it. And one way the Earth is being affected is through the increase in coronal holes on the Sun. However, the fast solar wind coming from the coronal holes is not likely to cause a shift in the Earth's magnetic poles. This is most likely to be caused by the Earth having captured a new moon, which is in a highly elliptical orbit and causing a crustal displacement. Sorry, I wrote development there. Each time it reaches perihelion, and this is detailed in Article 167, as I mentioned before, anti-magnetic pole shift and crustal displacement. Now, such a recently captured moon would also be discharging the solar capacitor, and thus charging the Earth's ionosphere, and through this affecting Earth's weather. In other words, making storms much more severe. Such a moon would also cause strange tidal events and seismic activity, and may also be the cause behind the many sinkholes that have been reported around the world. The source for such a moon, the most likely source is, of course, the Planet X system or stellar cores. And we see this is evidence of these objects. And these images are from the Yoko satellite, Japanese satellite, and these are from December 14, 2001, which shows that these objects have been here for a long time. I have determined they may possibly have started coming in about 160 years ago. This particular system, I believe that these objects have come in before that. A lot of the gas giant planets are in fact stars that came in at an earlier time. But what we have now, it possibly started coming in about 150 years ago, is a whole system with lots of objects in them. And what we see here is one such object. This is an X-ray image, and these bright dots on this object are, of course, X-rays. And this means that this object is emitting X-rays. Now, the image these are very short exposure images. The exposure is only of about 1 second, perhaps even less. And the fact that the emitted X-rays allow the imaging of the object's contours. You can actually see contours on this object. You can see this curved line here that seems to be raised above this level. So there seems to be some kind of layer above this this other layer on the object, and there seems to be quite a lot of X-rays being emitted from that layer. And the fact that we can actually get an idea of the contours of the object through the X-rays that it is emitting tells you that these are actually emitted X-rays, not scattered. The moon would scatter X-rays, but stars emit X-rays. So this is most likely one of the stellar cores that have invaded the solar system, since it is emitting X-rays from its surface, and not just from one side of its surface as we'd expect a comet to emit. This one is emitting X-rays from all over its surface. And we can see that they seem to be more in the sun's corona here. There's a curved outline here showing that there's a spherical object there, and there seems to be another one here. So this is not the only stellar core. I believe many of these objects have come to the sun. Now, the way, of course, that we can see that this cannot be the moon is we actually have an image of the moon, and this is the night side. Of course, what we see here would be the night side of this object as well, since the sun is behind it. So we'd have to compare it with the night side of the moon. But this image from the moon, which captured the scattered X-rays that the moon does manage to scatter, has an exposure time which which is about 2,000 times greater than the exposure time of this image, because this is 1,899 second exposure, or 31 minutes and 39 seconds. And these are how many X-ray photons the moon managed to scatter in that time, and from its night side. So this means that this object cannot be the moon. Also, we cannot get any ideas to the moon's contours from scattered X-rays. Only emitted X-rays can give us an idea or allow us to image the contours and surface features of an object. However, sinkholes and tidal events may also be caused by large objects approaching the Earth. So it could be the moon or other objects approaching the Earth, although the crustal displacement that's leading to the poles shifting must be due to an object that is in orbit around the Earth. But other effects may be to other larger objects. And if we have these objects that have come in and have been in the solar system for so long, and these are stars, they most likely have brought planets and moons with them. So it's not surprising that the planets in the solar system may be capturing extra moons. We know that Jupiter, the largest object in our solar system, has gone from 16 moons to 69 moons, so most definitely has captured quite a lot of these objects. And I've written over the years about the evidence for these objects being in the solar system and having been here for a while. Now, the close approach of any of these objects to the Earth would affect the Earth's ionosphere through the electrical discharges that would be likely to ensue between the approaching object and the Earth's ionosphere. These would induce currents inside the Earth, which would lead to earthquakes and increase volcanic activity. Such currents can cause the whole planet to shake until structures inside and on Earth break and collapse, and thus lead to the appearance of sinkholes. In addition, the gravitational interaction between the object and the Earth could also grab the Earth, crust, and oceans. Tidal waves would occur in the oceans, and the crust would experience earthquakes. So in conclusion, an encounter between Earth and a large comet is likely to be cataclysmic. Mars seems to have lost its oceans and most of its atmosphere in one such encounter, and has ended up as a dead planet. For Earth, the encounter was also cataclysmic, and any other future encounter is likely to be cataclysmic as well, with most of the population dying and only a few surviving and having to start civilization over, as no infrastructure or technology is likely to survive. In addition, the Earth seems to be experiencing increased seismic activity, volcanic activity, sinkholes, tidal events, increasingly more severe storm systems, and shifting magnetic poles, most likely due to crustal displacement, which suggests that the Earth may have captured a new moon and may also be interacting with planetary-sized objects which may be approaching it at certain times. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.